Hi, this is Christian Reddy, and I wanted to tell you about a new image that was released by the Hubble Space Telescope. It's of the galaxy NGC 4631. It's the galaxy that appears up here in the upper left-hand corner of this image of a pair of galaxies. And this galaxy has been dubbed the Whale Galaxy because it kind of resembles the silhouette of a blue whale, you might say, swimming here in the oceans on Earth. It also has a companion galaxy to it. This is a satellite galaxy containing maybe a few 100 million stars at the most. It's a dwarf galaxy. It orbits not unlike the Moon orbits the Earth. And you'll also notice at the center there are a burst of new star formations, what astronomers call, in fact, a starburst. This is a region that's dominated by very hot, very blue stars that don't live to be quite nearly as long as our Sun. And when we take a closer look at it with the Hubble Space Telescope, you'll notice these little tiny blue dots speckling the disk of NGC 4631. The galaxy is alive with stars forming, and these blue stars are much hotter than our Sun. They are much more massive than our Sun, and they won't live nearly as long as our Sun. They tend to live a relatively short while, and then they die in supernova explosions. They quite literally explode. Also in this image, just to kind of prevent us from getting too confused, are this star right here. This is a foreground star that just happens to exist in the Milky Way and happens to be in the line of sight between us and NGC 4631. There is also another background galaxy right here. This is far beyond the distance of NGC 4631, so neither of these two objects should be regarded as have anything to do with NGC 4631. They are in the foreground and in the background respectively. Now, I talked to you about the hot stars that are living in these central regions, and many of these stars have already gone supernova, giving rise to these channels, these outflows of very hot gases that are shown here by the Chandra X-ray Observatory. These light-colored blobs are superheated gases that are rising above and below the disk of the galaxy, and in fact, the model that is believed to have caused this, the mechanism, are supernova explosions. These are the explosions of dying stars, and because their shock energy are blunted by the spiral arms of the galaxy itself, the rest of the outflows are kind of channeled effectively above and below the disk of this particular galaxy. So, when we take another look here with Hubble, we find there's a lot of star formation here at the center of the galaxy, but there is also star formation taking place right out at the very edges of this galaxy as well. Take a look at all of these blue stars. These are clusters of very hot, very blue stars that are being forged into existence. They are maybe only a million or 2 years old, or a couple of 100 million years old at the very most. These are very hot, massive suns. So, what causes all of this starburst, this star formation in this galaxy? Well, we talked about its satellite galaxy having a gravitational pull on it, and meanwhile, there at the lower left is this galaxy, NGC 4657. Notice how distorted the galaxy is. There's a hook on the end with a lot of starburst activity. The right side of the galaxy is highly distorted. This is a galaxy that's literally being warped from its normal shape, and this is a perfect example of how gravity can generate a very powerful effect on two galaxies that might be separated by hundreds of thousands or maybe even a million light years away from each other. And this is a bit of a preview of what's to come when our own Milky Way galaxy begins to approach the Andromeda galaxy, or the Andromeda and Milky Way galaxies appear to approach each other. So we'll be seeing sights like this over the next several million years, and we've already seen what is to come with colliding galaxies that I hope we can discuss in later talks. Well, thank you very much for listening, and we hope you enjoyed the show.